Hello friends, welcome to Catalyst Chemistry. As we discussed last class, important point about what acidity, okay, that is what acidity of phenols. Okay, before last class acidity of alcohol discussed. Okay, in acidity of phenol the most important part is what electron donating and electron withdrawing group. You know very well about that, that is a trick. How we are going to find out the acidity of alcohol, that is trick is the most important. That trick containing what 3 points. The first point is what easy removal of H plus ion, the second one is what low pH and low pK, the third one is what the negative should be less on CO minus. Okay, that is what most important part. Usually you are not able to find out the pH, majority pH. In that case you have to apply the first and second point. Okay, definitely you will get an idea. Okay, that is most important. While you are solving the acidity of alcohol and phenol, be alert on what which group is electron donating and which group is act as a electron withdrawing group, that is most important. Usually alcohol and phenols are there. Out of these two, which is a more acidic, they are going to ask you. The right answer is what phenol. The phenol is a more acidic compared to what alcohol. General formula of alcohol is means in this case what, if you are going to consider methanol, CH3OH is there. If you are going to consider what ethanol, that is C2H5OH. In C2H5OH means CH3CH2 is there. In this case what happens, the CH3 is act as a electron donating group. If the electron donating is there, automatic acidity of alcohol is going to decreases. In phenol is not like that. The benzene ring is act as a electron withdrawing group, automatically withdraw electron from the oxygen. Automatically what happens, the oxygen hydrogen bond is going to weaker, the hydrogen will go out easily. Okay, that is the most important point. Next, after that what I solved, that is what picric acid. Orthonitrophenol is a more acidic than what phenol. That point is the most important, bear in mind. After that metocresol will come, after that what paracresol, after that what orthocresol will come. Okay, those points are most important for what the entrance exam. Okay, up to this what acidity of alcohol and phenol is completed. Next, the major second part. Okay, you know very well about that, that is first point, acidity of alcohol and phenol. In today we are going to discuss that is second point is what esterification. Most important point, they are going to ask you what is the ester group. Ester group means what, very simple, that is just I am going to write here R is there. Next after that C double bond O, next in this case O, this one is indicate what R. This is the what ester group. This is the what ester group. Ether is different, ester is different. Ether means what, ROR dash, just here ROR dash. This is the ether. Ether is different, ester is different. Ester means what, R C double bond O, next one is what oxygen, after that what R dash. This is indicate what ester. Okay, bear in mind. Okay, next just I am going to remove this one. In esterification, the starting material is same. They are going to take a what, phenol or a alcohol. Just here in this case AR is there. Now, what is the meaning of this AR? AR means what, that is called alcohol, aromatic. That is indicate AR means what, aromatic ring. That aromatic ring containing what, OH means obviously the answer is what, phenol only. Just here in this case, just I am going to consider what, this is aromatic ring. In this case what happen, OH is there. What is the name of this one, phenol. Just here in this case what, AR is there, bar ROH means what, one is alcohol group, another one is what, just I am going to remove this one, AROH means what, that is phenol. Okay, if you want you can write separate, no problem. Separate means what, you have to take directly R, next one is what, OH you have to take, means what is the name of this one, phenol only. In this case, this one point you are going to consider ROH is indicate what, alcohol only. Okay, that is why in this case only one step is easy, better to understand. Okay, just here in this case the starting material is what, phenol or alcohol that can react with what, acid. After that they are going to add a H2SO4. After that what they are going to add a H2SO4. In that what, H plus means what, that is acidic media. Wherever H plus will come, try to understand very simple things, means that is what, acidic media. usually they are going to use what? H2SO4. In this case what? H2SO4 they are going to use. Again question, why they are going to use H2SO4? What is the role of H2SO4? H2SO4 can remove the water molecule. Just here in this case what? Remove the water molecule. Okay, that's why in this case what happened, this is what alcohol or phenol can react with what? Acid to form a what? This is the ester. General name of this one is what? Ester only, no? That is aromatic ester or aliphatic ester. Ester is possible plus release of what? Water molecule. In this case also same starting material, these two are same only. Okay, means in this case what I wrote means RO bond is there, after that H. In this case which cleavage takes place, they are going to ask you what? Obviously same, that is what? Oxygen hydrogen cleavage. I have not started carbon oxygen cleavage. The next point is there, that is what? Carbon oxygen cleavage, but in this case oxygen hydrogen cleavage takes place. Okay, this is the first point is clear. The next second one, just see here, in this case second one, this is also aromatic ring, after that this ROH is there, this is what? Alcohol or a phenol is the starting material. Next after that what they are going to add? Acid anhydride they are going to add. Acid anhydride, just see here, R dash CO twice, after that what? Oxygen is there, no? This is indicate acid anhydride. If you want, I am going to write a full structure of this one. R is there, next C double bond O, next after that R, next after that C double bond O, next this is indicate R dash. If you want you can write R dash. This one is indicate what? Acid anhydride. These two are same only. Here one oxygen is there, 2 CO, 2 R dash. Okay, acid anhydride. Acid anhydride can react with alcohol or phenol in the presence of H plus only. In this case also water removal, but in this case what happen? No problem, water is there, it will release, but it is not a balancing. Okay, that's why in this case product is possible is what? Ester only, plus release of what? R dash COOH. Means just here in this case also what? Oxygen cleavage takes place. Here is just bond is there, this bond cleavage R C double bond O, next in this case OH, the remaining what is left? RO C double bond O R dash. RO C double bond O R dash is the left. Okay, after that water molecule is going to remove. Okay, that is important. Means what? In this case acid anhydride can react with what? Alcohol or phenol to form a ester, no problem. The next one is what? Same starting material is only phenol or alcohol that can react with acid chloride. Okay, acid chloride. In this case also same, here is H is there, here Cl is there, HCl will go out. In the presence of pyridine, there is a formation of product is what? Ester only. Next question, why they are going to use a pyridine? Pyridine, it can neutralize HCl. Means in this case what? HCl release is there, no? That this HCl is formation of what? In a product. Okay, that is they are going to what? Neutralize, that will go out, act as a unwanted product. Okay, that's why they are going to ask you what is the role of pyridine. Pyridine can neutralize the HCl. Okay, that's why they are going to use a pyridine. Pyridine is a act as a base. Okay, I think this one, what is the structure of pyridine role, I explained in haloalkanes and haloarine. I think thionyl chloride is there, no? In that case. Okay, if you want you can refer my video. Okay, no problem. The next one is what? Important. This is most important. Okay, this question is asked in 2 times, JEE, and next one is what? NEET exam they asked. Okay, be alert on this one. Totally this the entire reaction is the most important for what? Entrance. Okay, CET also. Just here in this case title is means in this case acetylation of salicylic acid produces aspirin. The most important, in this case the most important part is what is the structure of aspirin. The next question, what is the IUPAC name of Esterification? The next they are going to ask you what is the common name of aspirin. In this case again they are going to ask you question, what type of cleavage takes place? Oxygen hydrogen cleavage takes place or carbon oxygen cleavage takes place. Okay, such kind of question they are going to ask you. Okay, that's why be alert on this one. After that they are going to use H plus only, that is what? Acidic media they are going to maintain. Okay, this is most important. Just here aspirin is there. This is what? Aspirin. What is the IUPAC name of aspirins? I wrote here. Here is there. This is the aspirin structure. I will explain after that. I will come to this point. Okay. Just here in this case what? This is a benzene ring, COOH. After that here OH is there. What is the name of this one? Salicylic acid. The name of this one is what? Salicylic acid. This can react with the acetyl group. Here is there CS3CO twice. Next one is what? This is a O. This is acetyl group. This is different. This is acidic anhydride. Comparison is the most important. Comparison study is the most important. Okay, you have to compare with other reaction. Okay, this is CS3CO twice O. This is not like that. This R dash CO twice O. In this case, what almost same only. No, if you are going to take a R dash means what, both are same only. There is no different. Both are same only, no. Acetyl here is also what, acidic anhydride, another name for acetyl group only. Both are same only, don't worry. In this case, what they are going to add a CS3, they are going to add, both of the groups are same. Okay, okay, right. Next, after that, what in this case H plus means naming means this is also acetic anhydride only. But in this case, which group, in this case, what, why you are going to confuse means, in this case, what I wrote, acetyl group I wrote. If you want a name means acidic anhydride or acid anhydride only. Okay, is it clear? Okay. H plus. After that, what in this case, what, there is a formation of what, aspirin. What is the name of this one? Acetyl salicylic acid. Acetyl salicylic acid. Just here in this case, what, COH, in the salicylic acid COH, and in this case COH, both of the cases what, same only. Difference is what, in this case, what, this oxygen hydrogen bond is there. This bond is going to what, cleavage. Okay, the oxygen hydrogen bond is going to cleavage. After that, in this case, what happened, that in this case, what, CS3CO is there, no, here is there CS3CO. Okay, this can react with what, that oxygen. There is a formation of product is what, it is also ester only. This is also ester only. Just here CS3C11O, this is look like a what, aromatic ring. This is also ester only, bear in mind. Okay, because of ester group is there, no, here is there no entire, this group is look like a what, ester only. That's why this will all comes in what, esterification only. This entire is what, esterification. Okay, that's why plus release of what, acetic anhydride. After that, they are going to ask you this question, asked one time in entrance exam. What is the IUPAC name of aspirin? Okay, this is a 2-acetoxy benzoic acid. Here is there, this is a 1, they are going to write this is 2-acetoxy, CS3CO minus is there, that is 2-acetoxy. Total this group is called what, a benzoic acid. Okay, up to this is called what, second point, esterification. The esterification means what, our aim is what, formation of ester only. Okay, this is important, bear in mind. Out of these entire this one, this is most important. Okay, in theory as well as what, entrance also. Okay, up to this what, the cleavage of oxygen hydrogen is completed. The next part is what, the cleavage of carbon oxygen is there. Okay, the heading, this is a B part, that one is A. This is a B part. The reaction involving cleavage of carbon oxygen bond in alcohol. The important point is what, cleavage. Cleavage means what, breaking takes place. The cleavage means what, breaking takes place. Okay, important. Just here in this case, the order of reactivity of different alcohol. In this case, order is the most important. Just here you know very well about that, the inductive effect. The one is plus I inductive effect, another one is what, minus I inductive effect. Plus I when takes place means what, if the electron donating group is there, plus I effect takes place. If the electron withdrawing group is there, minus I effect takes place. Okay, this is a fact. Okay, just here in this case, what, up to this what we have studied, oxygen hydrogen cleavage completed up to this. In this case, what happened, the carbon oxygen cleavage. Okay, this is important. Just here in this case, this some of the alcohols are there. Okay, I wrote only already. Just here in this case, R. In this case, how many R? 3 R means what, 3 donating groups are there. This R is indicate what, act as a CS3. CS3 can donate electron towards a carbon. This CS3 also donate electron towards a carbon. This CS3 is also donate electron towards a carbon only. Which effect is going on in this case? Obviously, the answer is what, plus I effect. Plus I effect. Okay, that is inductive effect, positive inductive effect. When in this case, obviously the electron density on the carbon is going to what, increases. In this case, what, electron density is going to increases. After that, what happens, this carbon start donating electron towards what, oxygen only. In this case also electron donating electron density is going to increase. But in this case, what happens, if electron donating increases means what happens, in this case, what, obviously the attraction between the oxygen and hydrogen is going to increases. That is why the hydrogen will not go easily. In this case, the hydrogen will not go easily. In this case, what happens, there is a cleavage of what, carbon oxygen takes place. Cleavage of what, carbon oxygen takes place. The next question is, why carbon oxygen cleavage takes place? In this case, the most important, this carbon is going to get a positive charge. The going to get a what, a positive charge, because the electron move from what, carbon to oxygen only. Obviously, in this case electron density is going to what? Increases. If electron density increases, attraction increases. That is why the carbon is going to break easily. Finally, I am going to get a structure like this. This is what R is there. I think this chalk is a visual or not. Okay. Here is there, here R. In this case, what the carbon is going to get a positive charge. Why carbon is going to get a positive charge? Because loss of an electron. Okay. In this case, this carbon is going to get a positive charge. This tertiary carbocation is a more stable. Next question, why tertiary carbocation is a more stable? Because of what? Hyperconjugative effect. The hyperconjugative effect is the most important. If you want, you can refer. Just go to playlist, you will get what PVC first year concept is there. Okay, one video is there about a hyperconjugative effect. Better you have to refer that one. Okay. I think in regular video only I am telling you what 2 to 3 times. So better you have to what go through that video. Okay, in this case what happened? Due to hyperconjugative effect, this tertiary carbocation is the most stable. That is why in this case what happened? The carbon oxygen cleavage takes place. Okay. The second thing means in this case this R is act as electron donating group, this R is also act as a donating group, electron donating group, but in this case what happened? Hydrogen is there. In this case, how many electron donating group? 3 electron donating group, but in this case 2 electron donating group. In this case what happens? Obviously electron density increases, the electron move from carbon to oxygen. Oxygen means what? This is going to get a more number of electron, means more electron density. In this case what happens? There is also what cleavage takes place. This is R, next here one is R is A, here is H. This is going to get a positive charge. This is called what? Secondary carbocation. This is what? Tertiary. This is what? Secondary. In this case also same, only one CH3 is there, only one electron donating group is there. In this case what happen? R CH2. This is also going to get a positive charge. This is what? Primary. Next after that this is what? Methyl group is there. This one is indicate what? CH3 positive charge. CH3 what? Positive charge only. Okay, in this case, that is why the most important point is in this case. Finally, I am going to write order. Tertiary, order of stability of carbocation. If you want, you can write a heading tertiary. Next after that secondary. Next after that primary. After that what? CH3 free radical. Okay, this order is what? Most important for what? Hyperconjugative effect only. Totally this concept is depend on hyperconjugative effect only. That is why in this case what happen? The cleavage takes place in this case most, because the carbon is try to get a what? Tertiary carbocation, because in tertiary carbocation is the more stable. Because in this case if you want, again I am not going to discuss that one, because of already I wrote a full mechanism of this one. Okay, better that video. Okay, up to this what? This is the reaction involving cleavage. The next one is there, that is what? Lucas test or a Lucas reagent. If you want, you can take a screenshot, I will check. Okay. Okay friends, I am going to end here only. Okay, next I will start what? Lucas reagent. Okay, that point we will discuss next video. Thank you friends.